a very high-level overview of what Polkadot is and what it has to offer as a platform to builders, developers, and businesses. So yeah, we will cover these things. I have some presentations that I inspired from. Can you see my cursor? Yeah, that's pretty good. Okay, and I have the links to them also here. I mean, you may have already seen these presentations, but I think they complement what I'm about to talk about here really well. So feel free to take a look. This also brings me to the next slide, where I talk about where you can find the slides with all the notes and everything. So all of the presentations I do are hosted and listed on my website as like just raw markdown. It's not like rendered, but it's a good way for you to find all the links and stuff. And a few words about me. My name is Kian Peymani. My username online is usually Kian Enigma. It's like some old joke that stuck around. Some friends chose this for me when I was 14, and 2 decades later, I still use the same username. I'm an engineering lead at Parity Technologies and a member of the Polkadot Fellowship, and it's my pleasure to be here with you all today. So let's get started with what is Polkadot from the perspective of builders and businesses who want to deploy applications on it, and talk further about that. So I would phrase Polkadot as a multi-core sharded blockchain, which can host other Web3 applications. I intentionally won't limit this to just can host other parachains, because there's more that you can do with Polkadot, which I will articulate further in this talk, and we'll learn about it. And Polkadot does this with what I would describe as in a very extremely scalable way, while retaining very high quality security guarantees, which is what is relevant and important to us when we're in the Web3 space. Before I go too further into the presentation, also feel free to raise your hand at any point if you have any questions. I'll try to keep an eye also on the chat if there's anything, but yeah, feel free to just raise your hand. And if not, at the end, we have dedicated time for Q&A. All right, I want to take a few minutes and talk about what Polkadot is not. So traditionally, blockchains were very sequential. Some blocks would come into the blockchain, and all of the validators would do some work on them, and then we move to the next block. And this would happen in a completely sequential manner. This is like how the old day blockchains work, and this is not what Polkadot is. Some blockchains have tried to improve this by using the same architecture, but just making it as fast as possible. So saying like, okay, these validators, they just really have to have like extremely hard CPUs and terabytes of RAM and petabytes of storage and I don't know, gigabit connections, and they all have to be in the same data center, and then we can process these blocks faster. And this is what we usually call vertically scaling a system and a blockchain. And this is, I want to emphasize, not what Polkadot is and what Polkadot aims to do. Then there are other systems that say, okay, let's actually split our validator set, which used to be like one big box here, into smaller subsets, and give them now work that can happen in parallel. This indeed increases our throughput, but it brings with it a number of downsides which are not desirable. A few of them to mention here is that if we actually go about splitting our validator set into smaller chunks, we would end up with different validator set groups that have different degrees of security. Some of them might be very high quality, some of them might be low quality, some of them might be running on great hardware, some of them on potato hardware, some of them might have billions of dollars of economic security behind them, some of them might have peanuts of security, economic security behind them, and that's not really great. So this is what I'm trying to get through with my creative use of emojis. So some of them are very secure, some of them are meh, some of them are terrible. This is what the original Cosmos model, for example, intended to do. And I would argue that the current sort of roll-up landscape in Ethereum is kind of similar, because different L2s on Ethereum, some of them are optimistic with like very bad properties, some of them optimistic, but they meet this like, I think, what was the name for it? Like stage 1 rollup, as this website that evaluates rollups in Ethereum calls them. What was the name of the website? L2Beat, yeah, as L2Beat called of them. Some of them are stage 1, some of them are stage 2, some of them are just not in the list because they're doing a really bad job and so on. Moreover, it's also worth noting that in this model, when we want to have like, yeah, thanks for sending a link. In this model, when we want to have this sort of like shards talk to one another, so one L2 talks to another L2, there are some challenges to it. One of this is that this communication, the turtle emoji, is slow and asynchronous. And this is more fundamental. It's harder to tackle it. And also crucially, it's kind of insecure, this communication, because if a L2 who is actually very secure, wants to exchange some tokens with an L2 that's, not so secure, it poses some, I would say, systemic risks. And this is also one of the flaws of this architecture, fundamentally. All right, and then we have, let's say, the fixed version of this, which I would say is what Ethereum is moving toward with this vision of native rollups. That okay, this idea of every rollup brings their own security and does their own thing is actually not really good. Let's have them all be like almost like equally secured and using the same infrastructure. And this does solve the communication security aspect, although the communication is still asynchronous and kind of slow. But crucially, in this model, we are securely scaling a blockchain to do more of the same thing. So all of these parallel columns of blocks that are going in, as you see, I'm indicating them here, they are all EVM transactions. So the variety of things that you can do in this blockchain is still limited to what EVM can encapsulate. And this finally brings me to like what Polkadot 1.0 was, and it's currently not the case, but used to be. Polkadot 1.0 was the same architecture. So our validators are divided into subgroups, but they all have the same sort of security guarantees. And we make it heterogeneous in that it's a sharded system where every shard is actually a completely different application. It's no longer all EVM. They can be any application, any blockchain, any state machine, whatever you want to call them. And this is why we came up with, we have this diagram here where each of these shards is a completely different thing. I'm using just some random examples. Maybe one of them is like something that's similar to Bitcoin. One of them could be Mythical, one of the current parachains. One of them could be Frequency, one of the current parachains. Or one of them could be Polimec, one of the current parachains. Before going further, I would like to emphasize that there is one important Polkadot terminology that I want to highlight here, which is that in the sharded architecture of Polkadot, we call each of these smaller subgroups of our validators that can actually handle one application, so this big BTC guy, a core. And this is like an important terminology that comes up all the time in Polkadot, and you should be familiar with it. Yeah, and of course, like Polkadot provides like a messaging infrastructure such that the communication between these shards are taken care of and they are completely secure. And then I would like to take it a step further. I phrase it to Polkadot 2.0. What Polkadot
There's a question, Kian, sorry,
yes.
in the chat.
Let me open the chat. What would be the synonym of core time in other chains? Interestingly, no such thing. Well, I mean, I would say the closest thing would be block space. The closest thing would be block space, but it doesn't exist in a one-to-one fashion. Because first of all, the only other chain, as far as I know, that kind of has the same thing is Ethereum L1. So Ethereum L1 also hosts this other blockchains on it called L2. But Ethereum L1 doesn't do like this proactive execution that Polkadot does and brings faster finality and so on. If another L2 wants to like attach itself to Ethereum, all it has to do is to use the data availability layer and like post some blobs into it. So it doesn't actually have a one-to-one example. Avalanche. So I'm not very familiar with like what kind of L2 system Avalanche exactly has, but there might be a similar thing there as well. But admittedly, I would say this idea of like a core, and then later on we learn about core time, is a Polkadot specific terminology, and it's understandable, I would say, when we look at the architecture of Polkadot and realize, okay, Polkadot is like this cloud, like Web3 cloud computer that is like multi-core. It can do, and each of the core can do some work in parallel to the other ones, and whatever sort of time you get in one of these cores is called core time, which we talk about later. All right, thanks for the heads up about the question. Now let's talk about the current Polkadot architecture, which is pretty much the same thing as before, but the realization was that the usage of these cores can be made more flexible, as in these cores are a powerful primitive. Let's make them as flexible as possible to be used. I didn't mention it explicitly here, but in this very old model, these applications were kind of like attaching or renting one of these cores for periods of around 2 years. And it was like very long, and it was like a high commitment for a lot of people. So in the new model, we have spread it in both directions. So one is that if an application wants to use a core for a shorter period of time, that's actually possible. Right now, the time period when teams acquire a core is 1 month, and they can always like renew it for the next month. Or they can even be on demand. So, there could be an application that says, hey, I don't have like a lot of usage for which I need to produce blocks. Because keep in mind, you only need to produce a block when your application wants to update its state. When it just wants to, when a lot of people want to read from it, you don't need to actually produce a block. You just, run your node, and that's about it. And for this, you can use on-demand core time. Moreover, there are teams that wish to actually use a number of these cores at the same time. So one team can say, hey, I actually have a lot of usage right now, or for this period of time, and I want to scale into multiple cores, and then I can have faster blocks. So because I can produce 2 blocks in parallel, my block time, instead of 6 seconds, is effectively now 3 seconds, because I'm producing 2 in parallel. So this is the feature that we call elastic scaling, and it's I think we're in the final stages of its rollout right now. As far as I know, it's already possible in a fixed fashion. So one project can say, hey, just give me 2 cores and I will use them, and that's already possible. But if you want a feature where it's actually like elastic and automatically happens, that is still being rolled out. Okay. Then the other terminology I want to bring to the picture is that Polkadot also has a number of these parachains that are essentially shards of itself. They are not an external team or project. It's actually like an extension of Polkadot itself. And we call these system parachains, the most relevant of which is called Asset Hub, which I'm denoting as AH. This is also one of the architectural wishes of Polkadot, which was for its relay chain to be as empty as possible and as much of the work, like application level work, to be happening on parachains. There are many more system parachains, but again, I think the most important one is this Asset Hub guy. I think there's one more question. Are all cores homogeneous? Do they all do the same thing? That's actually the point. No, they are. Sorry, yes, they are heterogeneous in that they can be different things. Although, of course, at the very core level, there is one protocol dictating all of them, and that protocol at the moment is that whatever is this application, it should be expressed as a WebAssembly blob. And this WebAssembly blob can have a few entry points that says what's a valid block, and then inside of it can do anything that it wants. So I would say they are not homogeneous. They're indeed heterogeneous. I don't know what word I used before. Maybe I said it the other way around. What I meant to say is that Polkadot is a heterogeneously sharded system. All right. Going further, I think it's useful as builders to have access to know like the statistics of Polkadot and what is going on in this blockchain right now. And there's a fantastic dashboard called Dot Lake. It's actually maintained by Parity. It contains a lot of like information about what is the usage of Polkadot right now, how many accounts are active, how many parachains are active, how many transactions are reproduced, and so on and so forth. And unfortunately, one of the misconceptions about Polkadot is that very often people look at the traffic on the relay chain and conclude it's dead. And that's kind of true, because there's nothing happening on the relay chain. Everything is happening on different parachains. I mean, if you look at this diagram, I think this dark pink is what's happening on the relay chain, and it's really tiny in all of them. And it's not more than, I don't know, a few tens of transactions per day. But if you look at like the action that's happening actually across Polkadot, it's tens of millions of transactions per day. So I think this dashboard brings a lot of insight there, and also demystifies that, the usage, or Polkadot is a platform that includes everything that's happening in individual cores, not just this relay chain blockchain that is securing all the cores. Yeah, and a few more words about like what is the state of Polkadot parachains and applications right now. I think we have around like 50 active parachains. Most of them have open channels to one another. They're sending messages back and forth, and they are diverse among many verticals of the industry. Frankly, I think there's a lot more than these 4 that I'm mentioning here, but admittedly, I don't follow or know every single of these 50 teams. But from this website, you can find the full list of all of them. There's also another like website that I want to like highlight here. It's linked here. It's a new one that is not like final yet, or it's not merged into the main Polkadot.com website, but it's living as a separate website right now, which gives a very interesting comparison that so far Polkadot has not been seen as a roll-up platform. But it can be. Like when you deploy a parachain on Polkadot, it's very similar to when you deploy, an L2 on Ethereum or a rollup elsewhere. And interestingly, what we see is that in a lot of ecosystems, there is a lot of conversation about how much revenue from transaction fees rollups can extract, because this is the main source of income for that rollup. And I would say, ironically, the conversation is that if a rollup can extract more fees, or it's like more expensive to use, the better. And for good or bad, in Polkadot, it's actually not like that, because Polkadot is so scalable that transaction fees are so low across the board that you can deploy a rollup much cheaper than you can deploy elsewhere. So in other words, for builders who want to deploy something, Polkadot is actually a few orders of magnitude cheaper than its competitors right now. And again, I find this ironic, because it seems to me that in the crypto Twitter, the more a parachain or a rollup extracts in terms of fees, the better. But I think that's actually not true, or not the right way to look at it. We should embrace the fact that it's so cheap to use this system, because when it's cheap for builders, it actually leads to being cheap for users. I think that's desirable. Like, we should not forget that this industry and this technology will not become mainstream as long as I have to use like $50 to, make a swap on a DEX. Yes, I'm a crypto enthusiast, and I'm willing to pay that $50, but my grandma is never going to do that. My aunt is never going to do that, or the rest of the world who is not bought into this ecosystem still is not going to do that. And coming back to the fact that when it's cheap for users, it's also when it's cheap for builders, it's also cheap for users. We can see that Polkadot has one of the really lowest fees for stablecoin transfers right now across the ecosystem. I think it's 0.5 cent. So I think that's actually a number that we can hope we can bring more adoption with. Another word about like Polkadot's scalability is that there was another very interesting experiment run late last year, where with collaboration between Parity and a number of ecosystem agents, there was a live experiment of spamming Kusama, which is like sort of the experimental copy of Polkadot. And the outcome was actually like very impressive, in that we managed to reach I think around 150,000 transactions per second across not all the cores of Kusama, but maybe like, I don't know, 1/4 of them or even less. So this really shows that, and the system didn't like really collapse under this rule, or none of the like finality was still like 16 seconds, block production was stable. And we hope to demonstrate with this experiment that our thesis is correct, that Polkadot is the most scalable platform out there without, compromising on the other security aspects. There is a fantastic report about the spamming. It has like very cool graphics and stuff. Again, I recommend you can have a look at it. And another word about like this resilience or security of Polkadot. I think it's interesting to put this spamming, which is one of the highest, if not the highest, one of the highest real TPS metrics ever experimented on live blockchain networks. And we put it next to the fact that Polkadot has like the highest Nakatomo coefficient between other platforms by like, a 5-time margin. So all that said, to bring it to a conclusion, all my sort of like shilling of Polkadot, what I want to get through is that Polkadot has an architecture of scaling horizontally through these cores that a builder can use one or many of. And it does this in a way that the security of network is equal among all of these shards or cores. And it seems like it actually works, as in like it's a battle-tested way where we can deploy applications that scale but remain secure. And while doing so, it remains cheap for builders, so you guys, and therefore it can still be cheap for your users as well. So you can have a hope at deploying a application that is, has the utmost Web3 standards because it's secure and it's still cheap for users to use, and you can bring more adoption. You can hope to have more people use your application because they don't have to faff around with like, $5, $2, $1 fee for every button they want to click. All right, so let me check if there's more questions in the chat. If not, we go to the next slide, which is, I would say, the most heftiest one in this presentation. So this is like my single diagram to summarize all the paths that you have as a builder to deploy something on Polkadot. So we have some sort of ledgers at the top with this tilted rectangle is a smart contract. The circles are a parachain. The ones with solid line are, or the parachains that are constantly producing blocks. The dash ones are on demand, and SCP stands for smart contract platform. So let's look at now all the options that you have. First is that you can be one of these on-demand parachains. So there could be one of the Polkadot cores that is just being shared among all the parachains that want to produce blocks on demand. And if you have a low usage application, this could be one of your avenues to build a blockchain, but one that is not producing blocks all the time, only when there is someone interacting with it. I think it's worth noting this is not like necessarily a bad thing. There are tons of Web3 applications, or at least I can name a few, where the ratio of reading from it and the ratio of writing into it are very disproportional. Something like ENS, like name services on Web3, which is one of the somewhat trendy things to build. This application has a lot more read than it has writes into it. So it actually makes a lot of sense for it to be an on-demand parachain. Next, you can be a sort of like persistent parachain that is constantly producing blocks every 6 seconds. And it can scale elastically, as we talked about, by tapping into another core when it has the need for it. So this would be the route of building a parachain. Then I would like to introduce a new product that is being built by the Polkadot ecosystem. It's called Polkadot Hub, but under the hood, it's actually the same Asset Hub parachain that we were talking about earlier. This Asset Hub parachain, by the end of this year, or hopefully earlier around September, August, is going to be upgraded to contain a number of new things. One is Solidity-compatible smart contracts, and all the dot native functionality. So all the dot balances, all the proxies and multi-sigs and governance and staking and so on. And you will have access to this smart contract environment, and your application can be one of the smart contracts that is deployed in here. So if Solidity and a smart contract is suitable for your application, this can be one of the routes that you can have. And while doing so, you can tap into all of these .native functionality. Your smart contract can interact with the governance system. It can create a staking pool of some sort, and so on and so forth. Also, it's envisioned that this Polkadot hub would be extremely scalable by actually leveraging our elastic scaling system, which is why you're seeing it's linked to multiple cores. So this hub is going to be like extremely fast, extremely scalable parachain. There's a question whether these Solidity compatible contracts would be EVM compatible. Yes, I actually mean the same thing. So the contracts are written in Solidity. They are not executed in EVM per se. They're executed in a RISC-V virtual machine that we'll talk about later, but it's 100%, let's call it Ethereum compatible. And whatever you can run on Ethereum, you can run on Polkadot Hub. And then you have other options. One is that there are indeed non-Polkadot. So this is like, again, it's a Polkadot system parachain. It's an extension of Polkadot. But there are other smart contract parachains that have been there for many years. And, that would probably be there for many years. And you can also deploy your contract there as well, if that is a fitting option for you. Such as Moonbeam is one of the examples here. It's a very known and successful smart contract platform, also Ethereum compatible, but it's not like it's not under the flag of Polkadot. It's a Polkadot customer who themselves provide Ethereum compatibility. And finally, there's another interesting option that is, I don't believe it's used by anyone yet, but I am, as an engineer and a technologist, I am convinced it's possible. And I'm not convinced, I am sure it's possible. And it's one of the interesting things you can do in Polkadot. So I want to highlight it. It is that no matter if you deploy your contract in the hub or in another smart contract parachain, or in both of them or something, and at some point you need more scalability than these guys actually provide, what you can do is that you can upgrade your smart contract to be a dedicated smart contract chain only for you. So you can start building a parachain that uses one of Polkadot cores directly, so it has more freedom in terms of scalability. But this is not like an open smart contract platform. It has the smart contract platform in it, but it only has one smart contract, and that is your smart contract. So you can leverage the same code that you had before, but you can tap into more freedom and scalability by this approach. In some sense, I would say Polkadot has always been trying to be the innovator when it comes to scalability. And this is another solution that we have in our back pocket. Again, as far as I know, not used by anyone, but I can assure you there's no blockers in implementing this. It's actually quite easy from what I can predict. Okay. I hope that was sort of understandable. Again, this diagram compacts a lot of information. Now I want to bring your attention to the ledger at the left side, which is that everything I said so far is what you build as the on-chain part of your application. So this is the code that you deploy either directly on Polkadot or indirectly via a smart contract, and it's running on-chain. It's in the umbrella of the Polkadot consensus, and it should handle probably the financially valuable, critical part of your application. But no application actually ends here. And you usually build a suite of things that live outside of the consensus umbrella. And I call this the off-chain part of your application. So this would be your wallet, another UI, if you have an indexer, if you need to integrate with an exchange. All of these things are code and SDKs and applications that are not ran by a blockchain. They are interacting with a blockchain. So these guys can generally interact with everything that was above it. And I want to highlight that there are two ways to do so. I'm being a little bit like redneck here by putting an emoji in the RPC, but I will clarify that a little bit. So generally speaking, all of these off-chain applications have two ways to talk to the blockchain. One is to call into an RPC server, be it run by yourself or an external provider like, I don't know, Subscan in the Polkadot ecosystem or Infura in the Ethereum ecosystem. And this is generally the fastest, easiest way to go. And for many use cases, it's actually the right choice. I took the liberty to inject some bias into this by putting this little emoji here, in that I think you should be aware that while doing so, you're putting your trust in the fact that this RPC provider is, not lying to you, is not censoring you, and so on and so forth. Something that we have seen misused Very rarely, but it has happened. So for example, when there was like a set of US sanctions against a set of smart contracts that were doing mixing of money for anti-money laundering reasons, no matter your political and moral standpoint, it was observed that most RPC providers in the Ethereum ecosystem blacklisted these contracts. So if you go to these RPC providers and say, hey, how much money I have this contract, it would tell you, go away. I'm not going to answer you. If you'd go to this RPC provider and say, hey, I want to transact with this contract on Ethereum, which is supposed to be an open and decentralized computer, it would tell you, no, sorry, bro, I'm not going to do that for you. Again, has happened, but very rarely, something you should be aware of. But the good news is there is an alternative. And in the Polkadot ecosystem, we have actually invested a lot of effort into it, which is that you would use a light client. So you wouldn't rely on a centralized RPC provider. Your UI, your wallet, your indexer, whatever, they would run a light client of the network within themselves, and they would rely on storage queries with some proof attached to them to both read information and submit transactions to the network. And not to say that this is 100% sort of like bulletproof, but it is orders of magnitude more censorship resistance than using an RPC provider. Because, in this case, only the RPC provider decides which applications I'm going to censor. In this case, you're connecting to the entire network. So all the nodes have to say, okay, let's ban this application. The likelihood of that happening is hundreds of times less, because 100 times more economically independent actors need to decide to censor something. And as long as one of them is, on your side, you can get through. All right. So for the rest of this presentation, with that said,
sorry to jump in. There's a couple questions if you wouldn't mind taking them in the chat.
Yeah, it's a good time actually. So, would this new Polkadot hub mean that an EVM protocol like we built at the join wouldn't need to launch our own EVM compatible parachain or launch on an existing chain Lamuzia, but we can launch our EVM contract via this hub? Yes, that's correct. So I would say if your application is currently written as Solidity, previously you had 2 options, now you had 3 options. Your previous 2 options was to go to a sort of like non-Polkadot but secured by Polkadot smart contract parachain, such as Moonbeam. Or you could do this dedicated smart contract parachain if you need it for any reason. And now you have the third option, which is the Polkadot hub. How many different RPC endpoints are there at this time, or RPC providers? I assume the answer is within the Polkadot ecosystem, and I don't know the exact number. I know a few names, again, like I think Subscan provides some things. There's another one funded by Treasury called IDP. I don't know what it really stands for. I think there's another one called Dweller. I'm probably going to butcher their name, but it reads a bit like this. Yeah, I don't know the exact list, but there is plenty. But does most of the traffic use one? Is there a preferred one? Again, I think someone has to ask, perhaps, the top 10 or a number of Polkadot deployed parachains and ask what they use. Frankly, I don't know what they use, and how sort of centralized it could be. The stance that we always take at Parity or the core Polkadot fellowship is to provide the options, and then sort of people choose what they want. We are happy that there are RPC options available. Again, exclude this devil emoji. Using RPC is not bad all the time. I don't want to imply that. But we are very proud and happy that using a light client protocol is also an option if you really want to do a critical interaction and you want to be 100% sure that this RPC endpoint is not lying to you or is not censoring you. And the choice is, I would say, based on your application and who you are and what are your desires and KPIs and so on. And just to give one example, I wouldn't mind as much if an RPC is censoring me on some, again, not financially relevant or not very significant matter. But let's say, you're a whale and you want to transact and your application happens to be blocked by some RPC providers. It's very useful in those cases that the slide client options is available because you are not landlocked into using the RPC. Let me actually jump forward a little bit, and I want to show this screenshot. So I have a slide later on about this light client stuff. What I really like, and I'm happy to see it, is that a lot of applications on Polkadot, when you connect to them, so these are like UIs, there is a setting button somewhere where you can actually select. You have the option, and you can say, hey, I just want to read some stuff. I'm not gonna and I don't care too much. I want a faster UI. I want a snappy user interface. Please connect me to an RPC. But if you want to be sure, or if you, for whatever reason, want more security, or you want to double check whatever the RPC is telling you, there's an option to actually connect to the light client. And this is how it usually is implemented. Okay, I think there was another question as well. Is there an SDK for this light client product? Oh, yes. So I will talk about it later in the talk. Okay. Yeah, and I think that the person who asked about the RPC providers, Brian, is indicating that there are trust assumptions. And yeah, I hope I have articulated that indeed this is like a trade-off situation. You can choose a faster option, connect to RPCs, you put your trust in that RPC. Maybe it's good for most cases. It's good that you have the option. Decision is up to you. All right, so for the rest of this talk, I will talk a little bit further about the SDKs and tools that you have available for first this part, the on-chain stuff. So if you want to build a parachain, if you want to build a contract, if you want to build this like dedicated thing, what are the SDKs? What are the entry points? I won't go into too much detail because I think next week my colleague Francisco actually has a lecture which goes into more depth of that. And then later I will do the same thing for this off-chain part. I'm not exactly sure when and who, but I believe there might be a follow-up lecture also on more details of this. For the rest of this talk, I'll keep it high level, just give you links, like entry points for you to look at until the lecture next week. So yeah, this is just a written recap of everything that I talked about in the picture. So let's start with the on-chain part. So the first most important toolkit that exists there is called, I would say unimaginatively or very predictably, Polkadot SDK. This is the software development kit that encapsulates everything you need to build these parachains. In fact, I don't talk about it in this talk per se, but a lot of teams have used the very same SDK to build blockchains that just don't connect to Polkadot. And that's, I would say, again, as an engineer, as a technologist, I think that's great. I really like that. It means we have created, an SDK that outlives Polkadot or exceeds Polkadot actually in some ways. I think one of the most popular ones these days that is relatively new and trendy is actually BitTensor. So this is a blockchain. It's been pretty popular, I would say, in the last year with the overlap of AI and blockchain. It's built on Polkadot SDK. It doesn't have any intention to connect to Polkadot, and these are also part of the things that are built with Polkadot. So this SDK is pretty low level. It's like really meant for developers to look at it. It comes with an official documentation portal that's pretty fresh. It's hosted now on the official Polkadot website. A lot of work went into it to gather all the previous sources into here. Will still be evolved, but I think at this point it's a good starting point. Also, this repository, this SDK, has a number of, I would say, unopinionated templates that you can use if you want to just tinker around. I want to highlight unopinionated because, end of the day, again, as maintainers of this repository, we want to give you all the options and all the foundations for others to build on top of it. So we don't go down the route of building a very specific template and then committing to maintaining it. Instead, we create generic unopinionated things that other teams can then build on top of. So there's a link to like a number of these templates as well, and a number of like getting started scripts and some guides and so on that are all in the README of Polkadot SDK. Speaking of these teams that build on top of Polkadot SDK, two of them that I find, I'm sure there's more, but two of them that come to my mind to mention here is that, for example, OpenZeppelin, the team that builds a lot of useful contracts templates for Solidity developer, has also built a number of runtime templates for Polkadot, and you can find them via the link here. There's another more .native team called Pop, Play on Polkadot. They have also built a lot of like high-level CLIs and like builder tools and templates and so on, where you can have a faster starting point when you want to build a parachain. So they give you like a better and more opinionated template to work with. Then we have the option of building Solidity contracts, as mentioned, or generally contracts, as mentioned. First is that if you want to go the Solidity route, we actually as Polkadot don't particularly invest time and effort into teaching people Solidity because this is like reinventing the wheel. Again, our Solidity tech stack is, our Solidity contract tech stack is completely compatible with Solidity. So if you go and learn Solidity from all the amazing documentations that are created by the Ethereum Foundation and the Ethereum ecosystem over the past decades, you're good. There's no difference between them. So you can just use those information. And again, to reiterating your deployment options, we can either go to this like sort of parachains that support our Solidity compatible smart contract infrastructure, such as Moonbeam. I think A-Star and Akala also have a variation of it. Or you can target this Polkadot Hub, which will come live later this year. Another small detail that I'm adding here, I'm not sure if it's like super relevant for you guys to know, but for those who are more curious, one technical difference between the two is that the sort of older generation of everything built in Polkadot was using WebAssembly as its virtual machine. So even this older generation of smart contract platforms, what they are doing is that they're taking your Solidity code and they are running it sort of like running it in an EVM that is running itself on WebAssembly. And with the new sort of Polkadot Hub, we're also introducing a new virtual machine. It's based on RISC-V, and it's called PVM, stands for Polkadot Virtual Machine. And this doesn't require like this one layer of one VM wraps another VM in that sense. We also have built a compiler that directly compiles Solidity code to PVM. So your contract would also run orders of magnitude faster when you're using this technology. So this is about smart contracts and Solidity. In fact, we have actually more options. There was also a long effort within Parity and now continued by the ecosystem to enable developers, especially those that already know Rust and are like particularly fond of it. As some of you might know, Rust is the most beloved language, apparently, as in those who use Rust love it the most. And I think JavaScript is one of the worst, that people who use it hate it the most. So Rust is one of the most used languages. So there was an effort, there is an effort since many years ago to create a nice Rust smart contract language within Polkadot as well. And this product is out there. It's called Ink. It's actually, it used to be a Parity project. Now it's maintained by the ecosystem. There are a number of teams. Again, some blockchains that are not connected to Polkadot are using Ink. Some blockchains that are connected to Polkadot, such as A-Star, are using Ink. And it has like fantastic documentation and showcases and so on. I don't really need to reiterate much here. Just click on this link if you want to know more. I think it's also worth noting that unlike EVM, which is a reinvented virtual machine, and it doesn't have a lot of languages that can compile to it. Like when you create a new virtual machine, you're kind of starting from scratch. The Polkadot smart contract machinery has been built either based on WebAssembly or this new RISC-V VM, which are much more ubiquitous virtual machines, which means it's actually much quicker to be able to iterate and say, okay, what other languages can compile to RISC-V? And let's now also add that to our smart contract language toolkit. And I actually recently found there is an example of this. Like, people have experimented with bringing Move as a smart contract language to a Polkadot parachain. I haven't looked too much into it to know like exactly sort of the state of maturity or like where it is. But the fact that this experiment exists speaks to my point here that WebAssembly and RISC-V, aka PVM, are ubiquitous VMs. So it's much easier to add a domain-specific contract language. That being said, I do want to emphasize, I think these are cool for tinkerers, but my sort of heartfelt advice to builders is actually to stick to Solidity as much as possible, because there is a lot more resources in it, and there's a lot more, it's been battle tested for a decade. I think it's reasonable advice to say sticking to Solidity is probably the safest option for most people. Okay, then I want to talk about like some tools that facilitate messaging between Polkadot cores, aka parachains. So this is not really relevant for those applications that want to live inside of one blockchain. So if your contract is here in Polkadot Hub and it just wants to talk to other contracts, this is not actually relevant to you. This is only relevant if you are like this parachain and now you want to exchange some tokens to Polkadot Hub. You want to send some message from one core, so it needs to come here and then arrive here. Or if you are a contract on Polkadot Hub, and now you want to send a message to a contract on this other smart contract platform, such as Moonbeam. So your message has to, come here, be sort of processed and secured by Polkadot, and then come back down here. For such interactions, this is like the messaging infrastructure of Polkadot. The language that is used to express these messages is called XCM, Cross Consensus Message. And as I alluded to at the beginning of the talk, doing this cross-blockchain asynchronous interactions is kind of complicated. It's also inevitably slow because you have to send a message and then forget about it and then wait for a response at a later time. And therefore, a lot of tools have been created by the ecosystem to facilitate this, to make these things simpler for developers to code, for testers to test, and so on and so forth. And I have a list of the ones that I find relevant here. I'm sure there is more. And again, might be something that Francisco next week in his lecture might go into more details of. Okay, before going further, let me address the questions. I think there's a couple around XCM. Can a parachain call the smart contract function on Asset Hub over XCM? Yes, absolutely. That's completely possible. Are there bridges between the Polkadot Hub and other chains like Ethereum Base? Oh, actually, I talk about this in the next one. So bridging. There are a number of bridges on Polkadot, and I want to iterate them. First is that Polkadot and Kusama are bridged. So that's kind of cool. There's also some, again, like cool, somewhat aspirational visions that we have in that, for example, Polkadot, I think when Kusama was announced in 2019, there was like a promise that Polkadot would donate 1% of its total issuance to Kusama. And with this bridge, we can actually do this in a completely trustless fashion. So, we don't have to send the money to Web3 Foundation and Web3 Foundation gives it to Kusama. It can actually happen over this bridge, and that's kind of cool. Or similarly, we can say, like Kusama has a voice in the Polkadot governance, or vice versa. Like maybe eventually there needs to be, or we can talk about a vote where we say we abolish the governance on Kusama, and the governance of Kusama is just the governance of Polkadot. These are all cool things that we can do with the Polkadot Kusama bridge. There is a bridge between Polkadot and Ethereum. It's called Snowbridge. It's not the only one, but it's the only one that is using the absolute security guarantee. So it's completely based on light clients, and it's the state-of-the-art bridge, which means it has very high security guarantees. It is admittedly, though, a bit slower than other bridges. But again, I think similar to my argumentation about whether you want to use an RPC or use a light client, you have a choice here. If you want to transact millions of dollars, probably you want to use this guy. If you want to send a quick $5, maybe you want to use a simpler bridge. There is a parachain on Polkadot called Hyperbridge, which actually does also trustless bridges with many chains, not just Ethereum, but it also includes Ethereum. And as far as I know, Moonbeam also has a number of common Ethereum bridges, not just Ethereum. I think it also has a number of bridges sort of attached to it, such as Wormhole and yeah, similar ones. These bridges do work on different sort of machinery. Very often they are working on the basis of a sort of like a multi-sig vault that is, you know, handling the funds. But again, I think it's a trade-off of how much money you want to bridge, how fast you want it to be, and what kind of security guarantees you want to have there. And I think it's worth mentioning, what about bridges between parachains? There is no such thing. Like all parachains are bridged together by default through being secured by Polkadot. Is ISMP related to XCM? I actually thought I added this to my slide. Yeah, okay, yeah, ISMP. So ISMP is also like a SDK, like a development platform that makes programming, sending messages to other parachains via XCM and receiving some data from them a little bit easier. Do you know if Hyperbridge supports Polygon? Actually, no, but I can quickly check. So you're not seeing my screen, but I am very quickly going to the Hyperbridge Hyperbridge app. And let me see if I can quickly switch my presentation so you can also see my tab. There we go. So Hyperbridge supports these guys at the moment. So what was the question? I kind of forgot which chain was the subject of the question. But yeah, you can easily come to the Hyperbridge website and check.
It was Polygon.
I don't see it. But I mean, I think it also depends on like sort of which destination and which source chain you use. But I think Base was also asked, so this is supported by Hyperbridge, at least. Again, I don't know all the bridges on Moonbeam as well. Maybe it's also worth talking about that. So let me open the link that I had to the Moonbeam bridges and open that here so you can actually see it. I don't care about this. So when you come to the Moonbeam sort of dApp, the main home dApp, they also have like their bridges listed here. Let's see, for example, if I want to go from Moonbeam, seems like it's Ethereum, but they have this other link to like other bridges, which I think the external bridges like Wormhole and stuff that support Moonbeam. And yeah, there's a lot to explore here and a lot of options. But I am not sure off the top of my head if Polygon is one of them. All right, let me come back to my presentation. All right. Okay. So that's good questions, and that's a few words about bridges, XCM, and the options you have there. Finally, I think it's worth remembering. So if you're a contract, if you're a smart contract, someone else has purchased your core time, you know, because either you're a contract that goes to someone like Moonbeam, and Moonbeam is already purchasing core time to run their parachain, or you're connecting to Polkadot Hub or similar, which is a system chain, and it has like sort of gifted core time. But if you are a parachain, you do need to sort of get your own core time. And there is like a dashboard for this as well in this .lake website with some links to UIs that, you know, show you exactly the mechanics of it and how it should be purchased. Similar to the fee story, I would say proudly that purchasing core time on Polkadot is actually pretty cheap right now. I think for a month you would pay, I don't know, like 20 dots, 30 dots, something like that. So, and I think that's something that should be celebrated because Polkadot has more throughput than people are using it right now. And this is like opportunity for a lot of teams, for all of you guys, or for a lot of teams. And two additional notes to add about it. One is that if you purchase core time in a monthly basis, you have a price ceiling on how much your price can go up. I think it's like, I don't know, 2-3%, which means even if the demand for core time suddenly goes super high, you're not going to be subject to that price increase. So you have predictable prices as a customer who is using Polkadot cores in the long term. And that's something that, at least from the perspective of builders, I would say is desirable. And the other option is that there is a built-in mechanism for auto-renewal. So if you really just want to say, okay, I know my core time for a month is now 20 dots, and I know the price is not going to go more than like, I don't know, 2% on top of this, you can enable this on-chain auto-renewal process where you fund some account with like 1,000 dots, and that's going to be for your next 5 years, and you don't need to worry about it anymore. There was a bit of an incident recently where I think 2 of our teams sort of realized a bit too late that they haven't renewed their core time. And I think this sparked a lot of like more attention to this auto renewal mechanism. And I think it's something that you should be aware of. And again, it's there. And I think now in the Polkadot wiki, there is a new article about it and how to use it. And I think the core time UIs that I've also linked here, they support this auto renewal mechanism. Another question is that into perpetuity, or is there a limit on the price increase freeze? So I believe the price increase for customers who are using the monthly core time is maximum increase 3%. So if the demand is off the roof and the price for the new guy is a lot, your price will only go up by 3% maximum. Forever, yes. Yes, unless if the governance apparatus of Polkadot decides to change that, which I think is very unlikely because again, there's less demand than there is supply. So I don't think it would make sense to do that. So yeah, right now there's more supply than demand when it comes to core time. Okay, so this was all about on-chain stuff. Again, going back to my diagram here, this is all about how you build and manage this part of your diagram. Whatever option you choose here, toolkits and links to use and build these. Now let's talk about the off-chain part. So how you go about building your wallet, extension, so on. So I would start by the foundational APIs. So these are like the sort of low-level APIs that support Polkadot, its parachains. In fact, they support any blockchain built with Polkadot SDK. So even the guys at BitTensor use one of these 3 libraries or a combination thereof to build their off-chain applications. And the main 3 that we support is one, because we love Rust, there is a Rust-based API. It's called subxt. The name is a bit historical, but yeah, it's like a Polkadot Rust API. And then we have 2 JavaScript/TypeScript APIs. One of them is a bit older and it's a bit more, I would say, opinionated. It's still completely maintained and will continue to be maintained. And it's called Polkadot JS API. And the other one is just called Polkadot API, aka API. This is the new one that, there's a lot of hype around it. And the encouragement is for a lot of teams to move to this. They have different opinions in terms of how they handle your types and how they do certain things, but they are, end of the day, competitors, and you can choose whichever fits your needs better. I guess the only thing I would just share here transparently is that this one is the more older one. This is a new one that is like developed in the last 1.5 years by a completely new team. So this I already covered, and I think I want to just to reiterate, the good news is that all 3 of the above are really like client compatible, in that whatever you build on top of them can have this nice option down here. Like in all 3 of them, if you go and find their Hello World example, they have a Hello World Lite client as well. And I think that's pretty cool. So you can always build something that has this option in it. A bit of a legacy or history note is that both this Polkadot JS API and this new one, PAPI, they come with something that we call a developer console or a developer interface. Maybe some of you have seen this beautiful website. These are not wallets. These are not UIs for your end users. One of the collective traumas of Polkadot is that for many years, people thought this is like the Polkadot wallet, whereas in fact, it was a Polkadot developer console. It allows you to do a million different things with a lot of control. And that's great for developers, but that's terrible for your users. Please don't expose this to your users. And in the new version, this is the PAPI version of that. Please don't, send your users to this website. This is for your developers to go and debug stuff. This is not for your users. And similarly, there is this extension that also comes with Polkadot.js. Again, I think this suffered from the same thing, in that it's a very opinionated, very offline, secure browser extension that maybe you're, again, maybe someone that seeks a lot of security should use. But for your users, you should probably advertise things like Nova Wallet, like Talisman, like Sub Wallet. I actually don't have them on my slides. I think it's good to just reiterate them verbally at least. Talisman, Nova Wallet, Sub Wallets. I would say these are the top 3 user wallets that you should advertise to your users, and they will they do support, again, all parachains, and they will support Polkadot Hub, and they are meant for your users. These are for your developers. So with these 3 APIs, in fact, you can actually build on all platforms pretty much, because these 2 are JavaScript. With JavaScript, you have options for web, CLI, desktop with React Native, and so on, and even with Electron and so on, and mobile with React Native and so on. So actually, these guys are multi-platform, same as this guy. This guy is in Rust, but you can plug it in with a Rust binding library that allows you to build desktop and mobile applications. And this guy is actually also has a feature that it can output a WebAssembly, so you can even build web applications with it. So these guys are pretty much multi-platform already. But if you want to know more, or some more specific tools that are built for different platforms, as I was mentioning their name earlier, Nova Wallet, one of the really OG teams in the ecosystem that has the best mobile wallet for Polkadot. They have open source SDKs that are probably a bit more high level for building Android and iOS applications and wallets and so on for Polkadot. So they might be of relevance to you. This is the courtesy of Nova Summer Technologies, the company behind Nova Wallet. Kudos to them. And for desktop, I have a few sort of other libraries that are built around Polkadot SDK. There is one for Unity. There's a .NET one, if that's still relevant for people. And there's even a Python one. Actually, the Python one is still used a lot. I would even maybe change my slides and put it here, as I would call it one of the foundational APIs, because it's very low level. You can build pretty much anything with it. And similarly, I think Python is fairly cross-platform, so you can port it to different platforms. There's a question, these are made by Nova. Does it require a white label agreement with them or not? Good question. I think the question goes back to what license they have used for these libraries. I haven't checked actually, but it's, I guess it goes back to the license. I would hope and imagine that, with the ethos of Web3 and, blockchains, which is everything is open source and very easily used in commercial places, they wouldn't have any restrictive licenses on this. But yeah, please check the license and use it based on that. Yeah, the mobile SDK, indeed, these 2. I can assure you that these guys have they don't have any stupid licenses on top of them. You can do whatever you want with them. You can commercialize them. You can change them. You can do whatever. But with the Nova ones, admittedly, I'm not sure. All right, I think that's almost the end of my presentation. I will spend maybe a few minutes about talking about one elephant in the ecosystem that has not been discussed in this talk, and that's Polkadot Jam. So Jam is a pretty innovative upgrade that is scheduled to come to Polkadot in the next coming years. There was also at some point a lot of confusion about it, but I hope by now it's more understood that it's not going to replace Polkadot or be a new blockchain or something. It's more like an upgrade. Actually, I can use one of my diagrams. It's an upgrade for this layer of our protocol. So this relay chain, this like lower level that pretty much no one uses directly. It's going to be an upgrade for this Polkadot relay chain. And it would allow these Polkadot cores to be used for more unopinionated or diverse set of applications. What I can say about it for the purpose of this talk and for you future builders is something to keep an eye on. Everything that you can do right now in Polkadot will be possible. Like, as in, will not change. Like, obviously no one wants to disrupt the life of all of these parachains that we have worked like 5-6 years to foster and so on. Everything that lives on top of Polkadot would persist and would continue to live, but much more would be possible. And I won't go into detail of it right now. Actually, on my website, I have like a few presentations and talks if you want to learn more about Jam. But it's something you might want to keep an eye on. It's also not just around the corner. Like I think in 2026, we will see the beginning of a staged upgrade of Polkadot to this Jam protocol. But yeah, I'm happy actually to talk about this more. But yeah, it's not directly relevant for today, so I kind of excluded it. And yes, Jam stands for Join Accumulate Machine, which is a very technical term for like the underlying mechanics of what it's doing. All right, that's it from my side. I will probably wait a little bit longer to see if there's more questions, and if not, we will end it. Thank you, Brian.
I have a couple of questions, if that's okay.
Yeah, please.
Okay. So the first question is, before taking things into production, let's say I have a favorite chain that I like to work on, say Moonbeam.
Mm-hmm.
Is it always a good idea to test things on something like Chopsticks, or do you prefer using the development nodes instead?
Development nodes. I mean, Chopsticks, I would say they're a little bit orthogonal in that Chopsticks allows you to test different scenarios on what I would describe as virtual forks of the chain. So you have a live chain. You want to see, okay, I want to execute this proposal on it, or I want to add this new thing to it. How is it going to behave for the next 30 minutes of its production? And Chopsticks allows you a very nice both user interface and a programmatic way to simulate this fork and see what's going to happen in that fork. I think it's one of the best testing tools built. It's built by Brian, CTO of Scytale, also one of the very one of the first teams that came to Polkadot, and they have built a lot of great tooling for us. I would say it's one of the options you have. I didn't get exactly what you mean by a development node, but I think generally speaking, from my experience, you want to do both depending on what you want to do.
Yes, that's right. Yeah.
Yeah.
Okay. My second question would be, would you recommend, again, this is a little controversial, but would you recommend using subXT over Puppy? Or is it the other way around?
Yeah, I mean, if I want to give my own opinion here, which, yeah, it's fine. I mean, you should know it's my opinion. No, I would say it's not. Because, JavaScript is a much easier language. There's a lot more resources on it. It's not type safe, and that's very often faster. Rust is kind of the opposite. It's type safe. You're going to be a bit slower, but your thing would probably be more written a bit more elegantly, but depends on the use case. I think some teams in the past have deliberately used subXT because everything else in their code base was also in Rust, and it made sense for them. But yeah, if I was building something, I would go with Puppy today. Yeah.
Understood. Yeah. Thank you.
Hey, Ken. Good training. Maybe asking the question that perhaps everybody has in their mind. How many of those tools are usable with ChatGPT, Claude, any AI tool out there?
Yeah, I mean, this is a evolving answer. I think a year ago I would say don't. Like it's very buggy because a lot of these AI models had like learning date cutoffs that were before we made tools. But I think I'm not like a 10x vibe coder myself to know all the latest AI trends and so on. But I do hear a lot of advancement there. Where you can really like fine tune these models. First of all, their learning dates are increasingly becoming up to date. So I think it is much better nowadays, and I would be more confident. There's also this MCP technology. I think there's a website called something Context. Let me see if I can find it. Yeah, it's called Context 7. Let me share my screen in a different way for you guys to see what I'm doing. Let me hide a few things and maybe share this screen now. I think nowadays there's an interesting thing called Context 7. For example, this MCP server is some technology that allows you to like put your own data into the AI so it can reason about that. So fine tune it with that. And this is like and the protocol I think is developed by Claude, like Anthropic, and it's being adopted by everyone. And there are like websites like this Context 7 that allow you to, they are running an MCP server and they allow you to give your own repository, and they would then host the MCP server based on that repository for you. So you can connect your cursor or like whatever AI tool you're using to the MCP server running by these guys. And actually a couple of us went a few days ago and made sure a lot of the Polkadot stuff is here. So for example, this Polkadot API, you see it's actually here and it's updated 4 years ago. So I think with cautious, so I wouldn't go to like, a model that I don't know when it's being updated and so on, but with cautious and such MCP servers, next to you, so you have high confidence, I think the usage of AI with everything, not just Polkadot, is just becoming a lot more safe, I would say.
Okay. Just a quick search on O3 model. I mean, I guess the Gemini is even better, but it says that it does support Rust substrate, design new palettes, configuring existing work through frame macros, so forth, right? So, I mean, why not, right? The question is how much would you like it to go out and to leak somewhere else, I guess, if this is an issue. So, but if you can run models locally. So basically my question was, is there like a workflow that you are aware of or you would recommend to use LLM tools to optimize or to make it more efficient Polkadot development? So basically that would be the question.
Yeah, I will describe how I use them, but I would give a word of caution in that I think, unfortunately, my way of using this versus someone who's new would be admittedly very different, because I've been working on this stuff for 5-6 years now, and I don't need them as much. For me, it's like a little bit of a small help, and if it's like hallucinating, I can usually correct it. Yeah, my general approach to them is that I have been using them since day zero. I'm not like shy of having these tools next to me, but I'm always cautious to double check everything that they're saying, and I'm aware that they can be wrong many times. As to other tools, I mean, the only other thing I can add is that the Polkadot wiki, so both the Polkadot wiki and this guy has like one of these, so it's like fine-tuned models on it. Polkadot wiki is where you can find information about Polkadot protocols, and not for developers. If you want to know like how does the core time model purchase work in Polkadot, for example, if you can ask such questions from it, and I think it does a decent job. It also doesn't do like something crazy. It just finds the right article and it will summarize it for you, and it would tell you even in which article it found it. So it's this one, for example. It's like a better search mechanism, I guess. And similarly, we have the same thing in docs.polkadot.com as well, which is the more developer-facing website. So this is where you can find like tutorials on, hey, I want to do XCM. I want to build like a Polkadot parachain. So they have like a tutorial called parachain 0 to hero. And you want to say, like, you can ask similar question. How to build my first frame palette, for example. So yeah, I mean, the only other like Polkadot specific help I can tell you is that these websites are equipped with decent AI additions. And they are able to answer questions on the web around the same website. And of course, you can go and use Gemini and ChatGPT and stuff as well.
Thank you.
Hey, Kian, thanks again. Brian here. I just had one more question with regard to test nets. Is that something that is used, or because we built on Polygon and Amoy, we were testing it before we went live. Curious if how you recommend that kind of thing.
Yeah, actually, I think this is a very important thing that I missed in adding to my presentation. As builders, you should know what test nets are ahead of you. Let's do an experiment, actually, and say, I would actually ask it here on the wiki. What are the Polkadot test nets that I can deploy to?
Specifically Polkadot Hub.
Sorry?
Specifically for Polkadot Hub.
Yes, I will address all of them, but now I'm a bit, if you don't mind, I'm a bit curious to see what this guy can answer. And if it gives a good answer, I would actually answer based on that. Yeah, okay, it's actually very accurate. So there are two major test nets for Polkadot. One is called West End. This one is more or less a mirror of Polkadot, excluding most of the external parachains. So if you want to test something that is more specific to the Polkadot itself functionality, like the governance and so on, you can come to West End. It's also very often used to onboard new validators. So if you want to like learn how to launch a new validators on West End, you can do it. Paseo is the other main testnet. It has all the parachains as well. So most external and internal, like system and external parachains, also have a mirror of their parachain on Paseo. And this is where you can sort of like test more holistic approaches. Or if you specifically want to go and deploy in Moonbeam, Moonbeam quite likely has like a parachain here. Although this is again up to the teams. I think Moonbeam also has their own test network that they maintain themselves. So it's a little bit specific to each team. As to finally your question about the Polkadot Hub. So Polkadot Hub is one of the system chains, and it will have, it's not live yet, but its ancestor or predecessor, I don't know the English word for that, but its grandfather, the Polkadot Asset Hub, is indeed already on West End. And I mean, it doesn't have all the functionality yet because it's not sort of live, but this one is a system chain, and it would be present on both of these test networks.
Is the Polkadot Hub being built by Parity as well, or is it is?
Yes.
Okay.
More specific to Polkadot Hub, I would add this as well. So we understand that this new, let me come here. So this is like a very new thing in Polkadot, and it's a deployment option to developers that was formerly not there. So we recognize that a lot of people want to play with this as soon as possible. And there is actually an answer to this, so I have it here. This is with a lot of warnings here, that this is a temporary documentation portal for those who want to specifically target Polkadot Hub with Solidity contracts. It's running a sort of clone of this Polkadot Hub on the West End relay chain as the West End Asset Hub, as we already described. And it also emphasizes that this is a work in production thing. This is a work in progress effort. And once the thing is officially live, this documentation will also move to the official one. But if you just want to try, okay, this new like Polkadot Hub, let me also open that back. This new Polkadot Hub, okay, I can write a Solidity contract. How is the workflow? What works, what not? This tutorial actually covers that a little bit. So you can connect. I think the first step is that you connect your MetaMask to this West End Asset Hub, and there's some very basic steps to like write a contract and remix and deploy it and so on. But more better docs around this would certainly come out throughout the rest of the year. I think actually very soon. So this is a temporary thing. All right. I think we are done. Maybe one of the organizers can confirm. I'm good from last week.
Actually, from our side as well.
Yeah.
Thanks, Kian.
Thank you, everyone, for listening and the good questions. If any follow-up, feel free to reach out to me. There's some contact information, email elements, so on, again, on the website. Yeah, happy to continue this later. And if not, have a good rest of journey in Polkadot and in this particular academy by Scytale and Polimec. And I wish to see you again.
Lovely. Thank you so much, Kian.
One last question. Where can we find the presentation?
On the website, on my.
Okay.
So if you come to this website under talks, it's actually the last one I uploaded today. It's not rendered. Again, it's like all markdown stuff, but you can find all the content here, including the notes that you couldn't actually see during the presentation.
Brilliant. Thanks so much for your effort. Appreciate it, man.
All right. Have a good day, everyone.
Thank
Goodbye.
you, Kian. Good day.
Thank you, Kim.
Thank you. Bye.